keep going. So yeah, thanks for coming along. So you all took tomorrow's sailing session so you could see this, I guess. So this week we're going to look at external collaboration. So this is what we do with share our file with the other consultants and build our model together and check things like clashes and stuff like that. So we're going to have a look at the external collaboration, how we share the BIM model, sharing documents, how we can share the 3D model, and reviewing the model and some future trends. So basically with the BIM model that we make, we can share it with lots of other consultants or lots of other stakeholders basically. So everyone from engineers who then take our model and use it to sort out structural design, stuff like that, other information providers, manufacturers, quantity surveyors, so they can take the costing of the project out of the model. The contractors themselves, so I'm not sure how up with some of the play you are on some of the stuff, but some of these contractors are able to work with like a virtual headset and have a look at the building on site and see where the steelwork's meant to go, say, and where it is placed, so that they can quickly check accuracy of on-site stuff like that. So it's just sort of one aspect of that. The building owners themselves, and sometimes they'll take our model and use it for facilities management stuff, so ongoing management of the project, so running of the building after we've handed over once it's constructed, basically. Developers will use it in their planning phase. Facility managers, again, for similar purposes to the building owners. Users, I think in Silta project, they were doing some virtual familiarization with the building. So news or staff would then walk through the building with a headset on, so that they knew that, or so they know that when the building opens, how they get from A to B in an emergency and all those sorts of things. The users, Stephen, welcome. And of course ourselves, building certifiers and government agencies. Now there's some countries now that actually demand electronic BIM building consent applications and stuff. And as time goes on, more and more that will become a requirement. So again, this all comes back to why we're trying to get through that it's important to model correctly and keep in mind all the BIM requirements of the project. So there's lots of file formats that we can use for BIM. Obviously for us, we tend to be using the PLNs, or the BIM Cloud Files, basically. We're exporting generally out of our project as ISCs or DVGs. BCFs are sort of an extension of an ISC that they can contain extra information in the file. So ISC will sort of export out a model, and a BCF is where we sort of can start recording all the clash issues like BIM Collab. So that then it makes it easier for everyone to manage the issues and get everything fixed as we go. And of course all these other formats, like, which is probably not strictly BIM, but they are used in the BIM process, like PDFs, XMLs, text documents, XLS, and Revit. So the International Alliance for Interoperability is sort of an organisation overseeing BIM development, and this is where the major providers like Graphisoft from Archicad, Autodesk, Bentley, all work together to try and come up with solutions for making it easier for all of us to share our digital models across platforms, so we don't have the situation where some consultants can only work in certain files because they're so tied up in a certain system. So this is all about all of us choosing a system of our preference and being able to work together and all have the same information available. So ISC, Industry Foundation Classes, that's our typical external file that we're taking in and out from engineers, HVAC, KSL, sprinkler designers, all those other people that we work with. So that generally takes the 3D data and allows everyone to see the model in a 3D format and has a lot of sort of information assigned to elements within the model, so everyone can sort of see what is what if it's been done properly. So again, it's a case of the model is only as good as the data we put into it. So it's no good building a really nice looking model if all the walls are told that they're floors and the floors says that they're windows and stuff like that. So it's really important to keep all that stuff accurate. So Open BIM, this is the sort of another industry group that works on sharing protocols and stuff like that. So that's BIM Smart. I think they're sort of here in Finland as well. So they are Building Smart. Oh, sorry, not BIM Smart. So they are an industry organisation for talking about BIM. So when we share our IFC, obviously it's a universal standard type file format. It makes it easy to share. So we take this out of our BIM model, and we turn it into an IFC, and then it can be used for all sorts of things. So like code checking, structural analysis, energy analysis, cost estimation, facilities management, HVAC design. So it's not just a pretty picture or something to look good on paper. It's actually being used for a lot more information, a lot more as a tool for building design process. Our IFC workflow, so basically we model it up and classify all the elements correctly. A lot of that classification as we go is sort of being done in the background anyway, so we'll be using like default type objects that have a lot of the information already built in as we want it, but just keep in mind that you know, it's always worth checking that what you're putting down is being classified correctly. So this is the basic data at least is getting, so that's like whether it's an external element or an internal element, load bearing, non-load bearing, just those basic ones, and also the so like the ArchiCAD classification. You can tell it that it's a wall or a slab or a roof or covering or whatever. So always just keep an eye on those sorts of things so that they can be accurate. And again, there are things that could be done either directly out in the object, or you can create schedules to go and check that all your elements are being classified properly, or all the relevant information is being put in the right place. So then we take our model and we can filter it out. So again, we would turn off the unnecessary stuff. So like if we're sending a model to the engineers, we would turn off like all the furniture, landscaping, just unnecessary stuff. So we would send them a IFC that dealt with just the structural elements, so roof, wall, floors, beams, columns, and the load bearing or the core elements of those. So we would forget about finishes and stuff like that. So it just keeps file sizes down and keeps things relevant. So then we would export that file. Then the consultant will import that file into their software, do whatever they need to do, send it back, and then obviously keeping track of which versions are which. So as a guide, the engineer's model and the architect's model are two separate models, and we tend to at this stage sort of model our model based on the engineer's, well, overlay it so that our model represents what the engineer's model says as well, rather than just inserting an engineer's model into our model and building around it. So sometimes we model a wee bit differently. So like in our case, although we've gone away from this, we might model columns stretching for the entire length of the column, so it goes across stories, whereas an engineer's model will have them separate, which is tending to what we do now. Our things like floor slabs, we model as just a generic slab of a certain thickness, whereas the engineers start putting these hollow core slabs in slab by slab, element by element, so they have lots of slabs in their model, whereas we've got one to do the same job. Model filtering, so this is where this is what our model might look like in our architectural model. So there's lots of stuff there that makes it look good for visual purposes, for sharing with the client and stuff. But when we want to send it to the structural designer, say, they only need the structural elements. So we can strip out any of this unnecessary facade work that's non-structural, just landscaping, and just stick with walls, beams, roofs, stuff like that. So then we export that out via IFC, and they can put it into their model. So the reference model concept, so that's where we are sharing our IFCs, and so like we are using, say, HVAC or SAR, and we're putting them into our model so that we can then develop our drawing, so we know where the electrical cabinets are, say, when we're preparing our elevations, plans and stuff like that. And again, same for them, they bring our model into their model just as a reference, and then build their model up and compare it to ours. So we're always going back and forward, checking each other's models basically to make sure that they're both similar when we get to the end, if not the same. So this is like how the engineers tend to model up their models with all of the details. So they'll have like all the joints and the beams, and each beam would be broken down sort of like a beam as well. So not like us, where we would tend to throw a big beam along the total distance of where the beams run. Engineers tend to break them up into smaller elements, as they would be on site. And then the model comparison, so we can compare versions. So if we have made some changes and we want to compare the difference between last week's model and this week's model, we can bring them together in the same authoring software like Celebra or whatever, and check where the differences are and see what the major changes have been. So XML is more a text-based format. So quite often we bring these in as like the landscape is on Ratamo. So the landscape file came in as an XML, and so that just is another way of transferring our data, not as a 3D model. And PDFs is obviously our standard 2D drawing transfer and change, so we can bring the PDFs into our model and model over them, but that's about as, and obviously export the PDF to show our 2D design work. So that's basically about all they're really good for. So sharing documents with our PDF. So we've got our model. We create our documents in our Plancy area, and then we can export these as PDFs, which obviously you're all aware of. And then we can get PDF details from manufacturers' websites and the like, and easily bring them in and incorporate them in our drawings if we need to as well, to make it quicker. DVG, obviously a short name for drawing. So this is more from the AutoCAD system. These can be exported both as and imported as 2D or 3D drawings. If someone does ask you for a 3D DVG, all you have to do is go into the 3D window and export as a DVG or save as a DVG, and ArchiCAD actually recognises whether you're in the 3D platform or the 2D side of the program, and it exports it accordingly. So if you're in a plan view and you export a DVG, it will export it as a plan, but if you're in a 3D view, it will export it as a model. So
is it possible to do 3D DVG?
Yeah. I only really discovered it not long ago myself, how to do it. It's just a simple save as 3D DVG. No, just save as DVG. No, it doesn't say it, just save as DVG.
So you have to sort of do it floor by floor in 3D?
No, just go to your 3D model and save, and it will save it as a full 3D model. So whoever's using the software at the other end can do that.
And can we check that in Solibri or reopen it back in ArchiCAD?
Should be able to reopen it back in ArchiCAD, or although you guys don't have very good DVG readers on your Macs, do you? No, I just bring it into a DVG viewer and check. Yeah, but it's a simple process.
The deal is just a matter of checking back what you and taking measurement. So
Yeah.
That one works well.
Yeah.
It's really faster than.
Yeah. And then for reviewing, we use the BCF, so the BIM collaboration format file. Now this takes our IFC, so like say with Solibri as an example, we would bring a IFC file into Solibri. We would bring engineers IFC file into Solibri, and then we start making changes, or not making changes, sorry. We start identifying issues, so we would create our issues. We would then put information basically with that issue. So it takes a picture of the issue, saves any relevant objects or elements to that issue. You can put notes about what the issue is. You can assign that issue to someone, like Ula, to fix. And then you export that in your BCF format, and all that information then goes with it and can be opened up by someone else, and they can see all that stuff, mark it all off. And if you're then using something like BIM Collab, where it's all done quite seamlessly, it'll go back to the web, and once you've clicked that you've done it, it'll show that it's been resolved by someone at a certain time. So
can we use Solibri to view BCF?
Yes, you import the BCF as that's the information that comes in alongside the data, the 3D file. So it's more the 2D information, but it ties up to the 3D file. So it's not, I don't think the BCF is like a file you open in Solibri and it brings the model. You have the model open, and then then you bring BCF into that file, and it brings all the data and goes to the place, or knows where the places are in the model that data relates to. And then in Google Earth, obviously you're able to export from SketchUp and ArchiCAD to place an object on Google Earth, if anyone's interested in that. And also you can actually go to Google Earth and bring back 3D information into ArchiCAD as well. And then this is another one, Universal 3D. So this is another open platform, open file format for sharing. That's just the Adobe one, but I don't know too much about that, so we can call it quits there. So hopefully that sort of gives you a little bit of insight into, external collaboration and data sharing, and again, why it's important that we build our models well. Because if we don't build good models, then they're no use to anyone. So just keep that in mind. Yeah. See you all next week. Cheers.
Could you set up, because I've got this Solibri viewer, but not